We're now going to continue our study of interfaces with something called the clonable interface. This is actually known as a marker interface and has that designation because it's actually empty. By implementing the interface, all we're doing is announcing to the rest of the world that our object is clonable. There are no constants or methods defined in here, but it merely indicates that an object which implements this interface has a particular desirable property, and in fact in this case the property of being able to be cloned. So the clonable interface tells that an object has the ability to be cloned. The implementation for the interface looks like you see here: package java.lang public interface clonable, and then notice we just have two parentheses with absolutely nothing inside because there's nothing there. There's nothing that we need to implement. So we simply say that we implement the interface and that has marked us as being clonable. There is a method in the object class called clone, which is used to clone objects, and it will check to see if an object has implemented the clonable interface before working on that object. In other words, you can't clone an object unless it implements the clonable interface. Well, so what does it actually mean when we say clone something? It means, as the name would imply, to make a copy of it, but somehow an exact duplicate copy. Now we've got an example here where we're doing some cloning. We have an array list called list1, and it contains a number of doubles. So we've added to the list in order the double 1.5 and then 2.5 and then 3.5. So there are 3 elements in our array list, and the list is called list1. Now you'll notice in the middle of the slide roughly we've created a new list called list2, and we've stated that it's the clone of list1 by implementing list1.clone. We're able to do this because clone is a method of the object class, and all objects, including list1, are members or descendants of the object class. So that's why we're allowed to do it. And when we do it, we basically get a copy of whatever was in list number 2. Notice what happens in the next line of code, however. We say array list double list3 equals list1. That did not actually clone the list. All we've done, in fact, is we now have two variables, list1 and list2, which refer to the same object. So in fact there is only one object, and it has two names effectively now. It has the name list1 and the name list3. However, list2 is a separate object which represents a clone of the original object. Any changes we make to either list1 or list2 at this point will not be reflected in the other list. However, since list3 and list1 are actually one and the same list, changes we make to either list1 or list3 in fact happen to both. So we can experiment with that to see how that pans out. In other words, if we were to add a new element to the end of list2 by doing a list2.add 4.5, and then we were to remove an element from list3 by saying list3.remove 1.5, and then we were to check what happened to list1, list2, and list3, we can confirm exactly that what I said earlier must be true. So let's start with the first, list1. What happened to list1? Well, initially it would have had the elements 1.5, 2.5, and 3.5, and you can see that the 1.5 that we removed from list 3 has now disappeared from list 1 as well. So in fact, when you consult the output in that red box there on the slide, you'll see that list 1 and list 3 are identical. That is, removing an element from list 3 also removed it from list 1. On the other hand, notice that it didn't leave list 2. The 1.5 is still there. Why is that? It's because list 2 is a copy of the original list. It's a separate object that lives in its own place in memory. It has its own reference, and what we do to list 1 or list 3, which are one and the same, do not affect list 2. That's why when we added 4.5 to the end of list 2, if you look at the output, you'll see that it's there sure enough as a fourth element, but it did not go into either list 1 or list 3. So to just recap this again, List 2 is an independent list. It was cloned from list 1. But list 1 and list 3 are one and the same list. And if you look in the middle of the slide, you can see the differences about how each of those originated. In the previous example, we cloned a list array, but you can also clone a regular array using the same clone method. And that's the example that we look at in this slide. So let's go through it. First of all, we declare an array of primitive integers called list1 containing the two primitive integers 1 and 2. In the next line of code, we clone that list by saying list2 equals list1 dot clone. Now understand that we now have two separate arrays. They are independent, but one happens to be a cloned copy of the original. So when we do list1 dot sub 0 equals 7 and we overwrite the 1 with a 7, we're only going to see that change take place in list 1. It won't affect list 2. List 2 was originally cloned, but now it lives as an independent entity, and changes we make to list 1 do not affect it. Similarly, changes we make to list 2, the clone, do not affect the original. So when we say in that fourth line down, list 2 sub 1 equals 8, that will overwrite the 2 in list 2, but it won't have any effect in the 2 that's back on list number 1. At the last two lines of code, we actually generate the output to prove this. The output looks like what you see here in this red box. And sure enough, list 1 has become 7 and 2, whereas list 2 has become 1 and 8. So the 2 stayed in list 1 and the 1 stayed in list 2. But the changes that we made to each list are independently present. So we have a 7 in list 1 only and an 8 in list 2 only.